good morning everybody. This is Aqsa Fatima, Assistant Professor in Department of Myself Engineering College. Today we are here to see another topic of renewable energy technologies, that is geothermal energy. So geothermal energy, before moving on towards what is geothermal energy, let's see what all we are going to cover in today's topic. So today we are going to see introduction and what are the geothermal reservoirs present and where are the geothermal reservoirs and how the extraction of geothermal energy takes place and the uses of geothermal energy, how the electricity is generated using geothermal energy and what are the cost and what is the geothermal energy scenario in India, and we will see the advantages and disadvantages. Okay. So moving on towards the introduction of geothermal energy, what is it? It's actually geothermal. The word itself signifies that geo means earth and thermal means heat. So geothermal energy is the heat from within the earth. So we can use the steam, the heat from the steam or hot water which is produced inside the earth's surface to build building for generation of electricity and for electricity being generated. So geothermal energy is one of the renewable energy resources which is replenished by the water which is being falling as a rain, and that goes into the earth's surface, then we use again further for the application of further different applications. Okay. Now let's see what are the before moving on towards what are the different reservoirs of geothermal energy. See here, if you see in this diagram, what is happening? The earth crust. So this is the a lateral section of earth crust, where you have the outermost layer, which is the crust. The second layer is the mantle. The third layer is the outer core, and the fourth layer is the outer core, and the fifth layer is your inner core. That is your magma and rock, whatever it is. Okay. So geothermal energy is generated from Earth's core. Okay, inner core. So which is about 400 miles below the Earth's surface. So from this area of the Earth's surface, the geothermal energy is generated. This area is hotter than the sun's surface and can continuously produce the heat, and it decays radioactive elements. It is a slow decay of radioactive particles and happens. This is all rocky area. So now, what is the first layer? It is mantle. First layer is mantle. Where what happens for the mantle? Mantle is around 2000 miles thick. Okay, so this mantle is around 2000 miles thick and it is made of rock. Whereas the crust is the outermost layer of the earth's surface, which is in the form of land. Okay, continents, ocean, land, these are all earth's surface or the crust. That is around 15 to 35 miles thick, and these are called plates. Okay, now deep inside the earth's surface we have geothermal energy. Okay. Now moving on towards where are the reservoirs of geothermal energy. So the reservoirs of geothermal energy are found in the areas where you have geysers. Geysers are the areas where the water springs out like hot air or hot steam. Okay, boiling mud points. Okay, boiling mud points and volcanoes, wherever you have volcanoes. So these all are geothermal reservoirs. So they can be used for your generation of and your extraction of energy from these things. Volcanoes, hot springs. Springs are the one which will have continuous flow of the water. But the hot springs are the one which will have hot flow of water through it all the year. Okay, every time you will have hot flow of the water. So the temperature and the water gets hotter and hotter. As you go deeper inside the ground, this temperature becomes hotter. So the people around the world use these reservoirs to produce their heat, produce heat and also for electricity. They also use these as dig them as deep wells and pump water, heated water from underground, and they also use steams from this. Okay, so now see how is this geothermal reservoir forming these. Okay, the rising of hot water, that is your hot water will be rising from where it is rising from the innermost layer, that is inner core or from magma. Okay, it is rising and it is trapped in the permeable or porous rock. So this, if you see, there is a layer which will have your rocky area. This is around, see, we have seen in previous slide, right? This is around 2000 miles below the Earth's crust. So in that area, your rock will be formed. So those rocks will be porous so that they form a permeable layer. Okay, so this reservoirs can be discovered by testing the soil, analyzing ground temperature. So these porous rocks forms the geothermal reservoir. From the hot water from the below of the earth's surface will evaporate and will come to these reservoirs and get stored. And we can discover these reservoirs by testing the soil and analyzing what is the ground temperature. Okay, now how are these extracted and what are the uses of this extraction means? Okay, the heat energy can be brought to the earth's surface by falling directly from the hot springs or geysers and geothermal heat pumps and used. See, either they can be extracted directly or indirectly. Directly, if we see, they are extracted using hot springs and geysers, and indirectly, if we see, they are used by geothermal heat pumps. Okay, uses. So there are two types of uses. Either we have direct use or either we have indirect use. So moving on further, direct use is used for the yes. You see here the direct use of geothermal energy is used in hot springs, which are used in spas, heating water at fish farms. Okay, hot springs. The constructions are made in such a way that near the hot springs the spas are constructed, and for heating water at fish farms. So these are used in heating water at fish farms, and when you have heating of buildings or heating of surfaces, you use these hot springs, and also when you have greenhouse construction where you are raising the plants in greenhouse or drying crops, these are also used. The steam or the steam or the industry process for providing heat, or in the warehouses where you want heat to be provided, there you use this direct communication. Okay. So the indirect use of this geothermal energy is used when you are generating electricity in the areas where you have the porous rock present around at a depth of 3 to 5 kilometers, and you can use it. And the temperature for the source, that is the temperature of the steam, must be higher than that of 1.1 degrees Celsius. So these wells will be drilled and the steam from the reservoirs is used to drive the turbine and produce electricity. So usually it takes place by using heat present in the deep down under the earth's surface and at a depth of 3 to 5 kilometers. So these are drilled at specific areas where you have heat present at a depth of 4 to 5 kilometers, not more than that. And also we select the area specific way. You don't have to go very down such as what happens is geothermal energy is like a slow decay of radioactive minerals such as uranium, which causes so these rocks will be formed, right? So these rocks will help to form a plate which will will form exist and will form a reservoir kind of thing which will store steam and hot heat, which can be recovered from wells. These wells are drilled and there will be pressured out in the form of steam or water. So the types of electric generation. There are three types of power plants or the energy generation system of your geothermal plants. So these three are dry steam power plants, flash steam power plants, and binary cycle power plants. Okay. So what are dry steam power plants? So moving on towards we'll first see what are the components we need for geothermal power plants. So we need just to have an overview, we'll see what all the components we need. We need a production well, that is, you need a well which is drilled in UCL. This is injection. Here production is. So you need a production well which will lead you to the hot water or steam in the form of reservoir into the power plant. Okay, from here the steam or the reservoir will be used. Okay. You will need a stone catcher wherein they are placed. Make sure that only hot water or hot steam is sent to the turbine, and the rocks which are present in the production well doesn't go to the turbine and damages the turbine. Okay. Then you will have injection well wherein that will make sure that the water that is drawn up from the production well returns to the geothermal reservoir where it regains the thermal energy. Okay, and will again used for the generation of electricity. The next thing is that we need pumps, which was here also we need pumps and here also we need pumps. Pumps are used to pull the steam or the water, pump the steam or the water from the surface and send it to the turbine. Okay, now we also need turbine which will generate, the steam will move its turbine blades and create a mechanical torsion on the power shaft and will be used for generating electricity. And we need generators connected to the turbine so that the turbine mechanical energy is converted into electrical energy. And outside this, we need a condenser which will cool down the steam to water, and this condenser will be used to cool down this hot water into cold water and again send to the injection well. Okay. So these are the components of your steam power plant. Okay. Any of your geothermal power plant. Okay, so moving on towards dry steam power plants. Now, what we saw was the components which were used for these turbines. Now we will see what are the different. How does a dry steam power plant work? Okay, so dry steam power plants work by pumping cool water. So what it does is it works on pumping cold water into the earth's surface via one pump line. See, what it does is it injects cold water and it from production well it takes steam, and from through injection well it pumps the cold water back to the earth's surface. So now what happens is, at the high underground temperature, water is boiled into steam. Okay, from the geothermal reservoir. This is nothing but your geothermal reservoir. It's formed into steam and it goes into the from the pipes or the well, it goes into the turbine. Okay. Then the steam is brought to the surface by a pump. That is a production well, and it is passed through the rock catcher. Here you will have a rock catcher. Okay, passed through a rock catcher and directly sent into the turbine. Okay, the turbine is directly connected to the electrical generator, where it will generate electricity, and this is connected to the transformer, which helps in generating electricity, and this will be transmitted to the distances. Okay, part of steam goes through the condenser and turned into the cold water, and then enters to the system again. That is, here through the injection well, it is sent back to the system. So the working temperature of this plant, that is the dry steam plant, varies between 100 degrees Celsius to 320 degrees Celsius. Okay. So if the plant temperature varies between 100 degrees Celsius to 20 degrees Celsius, that means the heat energy is being that means the power is being generated through dry steam power plant. So the first geothermal power generation plant for dry steam was for this dry steam power plant was constructed in 1904 in Laredo, okay, in Italy. So this had a capacity of around 250 kilowatts when it was being constructed. Okay, so this is a very simple method where you have a temperature range of around 150 to 300 degrees. Okay, so these were also used very conventionally. That means they are the oldest type of geothermal power plant existing, and but in this geothermal power plant, what you need is a pure steam. Okay, pure dry steam you need. They can't contain moisture. So these are very rare type of geothermal power plant, and it's operating at California, Italy, and Japan. Now you have flash steam. Flash steam is the most commonly used in nowadays. So it requires a temperature of at least 180 degrees Celsius or more. So what happens in flash steam power plant is the water is pumped under great pressure from the underground. Okay, it's pumped with the great pressure, and when it reaches the surface of the earth, the pressure is being reduced and causing some of its fluid to rapidly vaporize or flash. Okay, once the see what happens when the pressure is high, this water will be in full pressure, and once you reduce the pressure, this gets vaporized. So these vapors are used to drive the turbine. Okay, drive the turbine, which in turn drives the generator. And the turbine is drives the generator, and the generating station produces electricity. And these generating stations are connected to the utility services that convert which will step up or step down the verticals and use as it is required. And the cooled water will return to the reservoir by using a serpentine condenser, and it is condensed using this serpentine. Okay, so this is sent back to the condenser to the injection well, and this is where you have your process completed. So this is how the flash steam turbine works. What is happening in the flash steam turbine? That these are extracted at a great pressure from the earth's surface, and once it comes to the surface of the earth, the pressure of this is reduced. It turns it into the vapors, which in turn causes them to form vapors, and these vapors drive the turbine. Okay, so these are the most commonly used turbines nowadays. You can see them in Japan. You can also see them in Imperial Valley, California, West California, East California, and Nevada. Okay. Next is just you can see that these are the commonly used geothermal reservoirs which can use both hot water and steam to drive a changing system. That is a flash steam and nothing like a irrigation system. They are used in Nevada, Utah, and some other places. The next turbine system for the next power plant for the geothermal is your binary system. In binary cycle power plant, it is a power plant that allows cooler geothermal reservoir to be used. That is, the injection well it is sent back to the geothermal reservoir. Okay, and pumps are used to pump hot water from the geothermal well to the heat exchanger and cold water to return to the underground reservoir. The second working or the binary fluid with a low boiling point is pumped at a high pressure to the heat exchanger, where it is vaporized and then directly sent through the turbine. So this after pumping it from the ground, then again you are using another pump for the second fluid or binary fluid, which is boiling water at a low temperature or the heat exchanger. That's the reason this is called a binary cycle power plant. Okay. The vapor existing in the turbine is condensed by cold air and radiated back to the. So what is happening once this is forming a hot air at high pressure? It is getting vaporized and it is being sent to the turbine. So these binary cycle power plants are also used by the vapor exiting turbine. So here if you see binary power plants, what is happening is we are using a heat exchanger which is increasing its boiling point. That is, it is making the water into completely vapored steam. Okay. So this binary cycle vapor is defined in thermodynamics as a power cycle, and it's a combination of two cycles. And this operating turbines of this geothermal fluid temperatures is ranging between 85 degrees Celsius to 170 degrees Celsius, and the vaporized hydrocarbons are used to spin the turbines. Hydrocarbons will be having much lower boiling point. So with those hydrocarbons are isopentane, isobutane, and propane. And during this binary cycle power plant power generation, there will be no harmful gas emitted in the atmosphere, and the water which is being used or the fluid which is being used is recycled and reused again. So environmentally, these binary cycle power plants are environmentally advantageous, and the key advantages of this is they don't release these hydrocarbons to the environment. They are again reused in the cycle itself, and the thermal efficiency of this hydrocarbons is around 10 to 13%. Okay, these are the turbine generators which are being used for the generation of electricity in the all the three power plants, that is steam power plant, dry steam power plant, flash power plant, and also in binary cycle power plant. So the turbines are constructed in such a way that the steam which is being used is going out through the outlet and is getting condensed in the condenser. Now, if we see the cost efficiency of these power plants for the indirect electricity generation, in direct use, these are absolutely cheap. They can be used and they can be installed in a very environmentally friendly way. Whereas when using for the generation of electricity, it depends on temperature, depth of the resources, the temperature for what it is being operating, and the depth from where you are extracting the geothermal reservoir. The types of resources, that is steam, liquid, or both steam or liquid. If you see in flash turbine, we used both steam and liquid as it was being converted to vapors. Whereas in your binary cycle power plant, you used vapors, and for the flash for the dry steam turbine, you used completely dry steam. Now the next factor which we will consider will be available volume of resources. How much volume of resources are available at the present geothermal reservoir must also be kept in consideration, and size and technology of the plant. See, if you are installing a plant with less electricity generation, it might not be of that use. So you must install a power plant which must have at least a generation of around 250 kV. The next thing what you must consider is the initial. So here the initial investment of this plant will be high, but after the certain time period, the cost of electricity becomes comparable to the resources of the energy. So if you generate the electricity with this, you might vary the cost of it as 2.772 to rupees 4.43 per kilowatt hour. Okay, so once if your investment cost is being retrieved from the generation, then your price can be decreased to 2 rupees. Now let's see the areas where the geothermal energy plants are being installed in India. So if you see the map here, the geothermal locations of geothermal reservoirs are present in Himalayas, where it is in Kuga Manikarnan. In Delhi, it's in Sohana. In Gujarat, it's near Tuwa, and part of Jalgaon, Sonata, and Tatapani. In Bhutan and Godavari. The geothermal province of India has an estimated power generation of 10,600 megawatts, and this extracted power is at least 100 megawatts of generation. So just now we have seen in map the areas which are having the province of geothermal generation in India, or the reservoirs in India, are the Himalayas, Sohana, West Coast, and also in Jammu and Kashmir. So the first operational power plant is of 25 megawatts is to be installed in AP with a capacity of 25 megawatts by Geo Syndicate Private Limited. So if you see the advantages and disadvantages of geothermal power plant, so the advantages of geothermal power plant is that your energy is being utilized for all over the year. It doesn't vary with the change in the climate. The heat inside the earth is always the same. The magma, the reservoirs, the geothermal reservoirs doesn't vary. Then it doesn't involve any combustion of fuel. That is, there is no burning of any fuel, no fossil fuels getting exhausted, no lack of resources. And this geothermal power plants are also independent of your weather change, and these are clean resources with little emission or no harmful chemicals being emitted to the environment, and these are also economically friendly, and the rate or the price for the generation of this electricity is much lower than that of the other power plants. So it is a sustainable energy resource. Then moving on further, we have disadvantages. So these the main disadvantages of this resource is that it is not widespread. It can't be used in the areas where there is no presence of geysers or your boilers present, and the installation cost for this is high. And other disadvantages is that it is not necessary that the steam is being released throughout your generation process, and the transmission of energy sometimes takes high cost, so it can be used within the confined area of the utility grid. And there might also be a problem of earthquake, which might destroy the wells which we are using to extract the water from the earth's surface. Now the conclusion for this is the geothermal heating system can replace fossil fuels heating systems in particular areas. The annual cost for this is can be reduced to around 60%, and energy can be stored. Geothermal power generation is also high. So the applications of this geothermal power plants are that they are used in space heating for direct use. On the direct usage, they are used in space heating, greenhouse gases, greenhouse effect. That is, where the plants have become hot water plant, hot water, direct hot water, air conditioning, aquaculture, external drying, industrial plants, etc. And for the indirect uses, they are the geothermal. They are the so with this we are only this house of